Hello everybody, I am A. Krishna Patro, Associate Professor in the Department of Computer Science Engineering. I am from IIRE College, Institute of Aeronautical Engineering. So today we will discuss about one more new topic, that is queue using linked list. How to implement a queue. So in the previous session you have seen something called stack. Stack is a linear data structure. Similarly, the queue also one type of linear data structure. It follows a order called FIFO order, first in first out order. So in the definition you can say queue is a linear data structure which follows a particular order in which operations are performed. The order is called first in first out order. That means whichever comes first you have to do first. And queue having some set of operations. Those operations are enqueue, dequeue, is full, is empty. There are various operations. In addition to this, there are two standard items are there, constants are there, front pointer and rear pointer. Or you can say front method and rear method. Enqueue is nothing but inserting an element and dequeue is nothing but deleting an element. So whenever you want to insert an element to the queue, you will call enqueue. And enqueue will allow you to insert until the memory is available. Once memory is over, then it is a, either you can say queue full. Queue full. Okay. Similarly, dequeue is another operation. You can remove the item from the queue. As long as there is element available, you can delete. If elements are not there, then you can say queue empty. Queue empty. Okay. Similarly, there is another method called is full, whether queue is full or not. If it is full, it returns true, otherwise return. Is empty. There is another method checks whether queue is empty or not. That means it will give the boolean value, true or false. Similarly, front, it will give the front element. Similarly, rear, it gives the rear element. So, in a queue, you can have set of items. This is your front part and this is generally your rear part. So, in the front part, always you can delete, and the rear part, you can insert. So, these are the two pointers generally useful for insertion and deletion. Generally, you can differentiate through a diagram also. The stack is represented in a vertical way, whereas the queue is represented in a horizontal way. Like this. You can represent like this. So, whenever you are representing the array in a vertical manner, that is stack. Whenever representing array in a horizontal manner, that is queue. So, this is a general representation of stack and queue. And the first element is called front element. The last element is called rear element. Okay. And in the case of stack, the top element is the place where you can do insertion and deletion. Where in the case of queue, this is a queue. Here you can do deletion operation. And here you can do your insertion element. Okay. Where in the case of stack, at the top only you can do push as well as pop. So try to remember these two things. And here the program you can write using Python. A node can be represented like this, because when you are representing the node using linked list concept, you have to maintain two things: data part as well as the pointer part. Data part is the real data, and the next is a pointer pointing to the next node, because you have to represent the set of nodes using linked list. So I am maintaining a class called queue linked list, LL linked list, and here I am maintaining two pointers, rear pointer and front pointer. Initially rear is none, that means it is empty, and front also none. So this is the initialization condition. And while inserting a node, please observe here how to write a program for this. Read the data first and get the new node. That means you are passing the data to the node. Then check whether it is the first time or not. If self-read front is none, it sends front is pointing to nowhere. It's first time. So self-read front is new node and self-read rear is new node. That means in the first time, first node is rear as well as first node is front. Second time onwards, only rear will be changing. Rear dot next is new node and rear become new node. So the front will not change. So while inserting an element into the queue, First time, this is front and this is rear. Front and rear both are same. Second time onwards, this is front and the rear is changing. So like this, changing. Okay. Third, again, front is same, the rear is keep on moving. Like this, it is moving. So this is the way you can insert an element into a queue. So try to remember this else part is the main one. This is a simple code to insert an element into a queue. You can observe through this animation way. Initially, when there is a single node, rear is pointing to same 4000 address and front also pointing to same 4000 address. And my data is 23 and next is none. That means single node is there. If some more nodes are inserted, now my front is same 21 and whenever I am inserting 22, this rear is changing. Rear becomes this 3000 and this is my 3000. 3000 is the address of the new node. So it is pointing here because you are maintaining like a linked list. My starting position is always fixed. So this is the way. Assume you want to insert one more. If you want to insert one more, for example, my data is 23, whose address is 4000 and it is pointing none. Whenever you want to insert, this 4000 will be replaced with none. So here 4000 will come. And the rear is moving forward. So that means the rear will come down. Rear. So self dot rear is how much? Now 4000. So it is pointing here. So that means when you are inserting, the rear is moving forward. Front will not change. Remember while enqueuing, your front will not change. Only rear is moving. Like this you can move. Of course, here you can put a restriction also. How many nodes you want to insert? If there are 3 nodes, after 3 you can say it's full. So you can maintain a counter. So using the counter you can put a condition. Of course in the linked list, only the constraint is only memory. No need to put that condition also. Yeah. So like this it is setting. Now when you want to delete a node from the queue, that operation is called dequeue. Remember the two enqueue and dequeue. There are two important methods. If front is none, queue is empty. If self.front and self.rear equal, that means pointing to same node. That means only one node is there. This is the single node case. This is single node. When there is single node, then that node will be deleted and front and rear is none. And is none. Else, if more than one nodes are there, that means front and rear both are not equal. In that case, my front node data has to be removed. So initially temp equal to self.front and front data has to be removed and self.front equal to self.front of next. That means front is moving forward. When it is moving forward, the temporary pointer which is pointing to earlier front, that is removed. So dequeue is the separate method which allowing you to delete the element from the queue. So this is the way you can implement the queue using linked list. Okay. So you can see the animated way of representing. When there is a single node, that will be removed. Then rear is none as well as front is none. When there is a single one. When there are multiple ones are there, my front has to move forward. Now here the front is now 21, whose address is 2000. If you want to delete this one, now this node gone. Now the front become 3000. That means the second node's address has come here. Okay. So front will be deleted. If you want to display the element of the queue, check whether front is none or not. If front is none, that means there are no elements at all. So you can say empty. If elements are exist, then you start from front, temp equals self.front, and what are the elements are there, you have to repeat until you reach NASH. So after getting the starting address, you print the data and temp equal temp of next. So temp is keep on moving forward until it ends. Okay. So this is the way you can display all the elements of the queue. Start from front and keep on moving until you reach none. The none indicates end of the queue. Okay. There the application of the application of the queue. When the resource is shared among the multiple consumers, then CPU scheduling or disk scheduling, that time internally uses the queue. Second case, whenever data is transferred asynchronously, that time also it uses IO buffers, pipes, files, etc. There also it uses queues. Similarly, handling interrupts in a real-time system. So multiple interrupts are coming. So those things also uses queue internally. Similarly, in real life scenario, call center phone systems uses queue to hold the people calling in the order until the service event is free. Queues are useful in many cases, whichever follows the first in, first out order. So all these things are first in, first out order. Before. Okay. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.